Hi, in this video I'm going to talk about question number 8 of homework 7 of probability and stochastic processes course. So let's go quickly to the question. The question is about Poisson process, and in the part A we want to calculate the expected value for Poisson process. Um, okay, if we want to calculate the expected value of x of t, we should calculate the sigma, which is x times the probability, the first order probability distribution function. But as we know this from the Poisson distribution, that this is hard to calculate. So we will do it indirectly. As you know, the sum of the probability distribution function, the probability density function for all of the events, this probability is equal to 1 for all events, sum of all events. So we can just substitute the p with the formula. And by knowing this, we can get the partial derivatives of both sides with respect to lambda, and we will get to something similar to the e of x. And then by doing some calculations, we can get to the expected value of x, which is equal to lambda times t. In the next part, we will need e of x to the power of 2, which is the process for calculating the e of x to the power of 2 is very similar to this process that I have written in question number 9, and I want to show you. So actually in question number 9, I am calculating the variance of x, which is equal to e of x to the power of 2 minus e of x to the power of 2. But for now, I'm just going to talk about the expected value of x to the power of 2. So we have this from the previous question. Again, by taking the partial derivative with respect to lambda, we can have some form which is very similar to the e of x to the power of 2. And again, by doing some calculations, we get to this part, that we know that the expected value of x to the power of 2 is equal to lambda times t plus lambda times t to the power of 2. Okay, let's go back to question number 8, and we want to use this. But for now, let's start part B. We need some preparation so that we can have the answer for R of T1 and T2. What are these preparations? First, we know that if T2 is greater than T1 for time range of 0 to T1 and T1 to T2, these two Poisson processes are independent. So by knowing this, we know that if these two processes are independent from each other, the e of the first one times the second one is equal to the e of the first one times to the e of second one. That's a great property. So we will use this. And from the previous part, we know that the expected value for n in the time range of 0 and T1 is equal to the lambda times T1, and for the second one is equal to the lambda times T2 minus T1, and by doing this multiplication, we'll get to the answer. And again, we know that we have this intuition that we have the number of events that is happening between time T1 and T2 is equal to the number of events that has happened between time 0 and T2 minus time 0 and time T1. So we will write this down, and we know that this is equal to the x of t1 minus x of t2 minus x of t1. And we have this assumption that t2 is greater than t1 in all these calculations, and I will tell you at last what happens if we talk in general. So we can write this, we can write e of n in between the time of 0 and t1, and n between the time of t1 to t2 is equal to, as we have here, is equal to x of t1 times x of t2 minus x of t1. So by doing this multiplication, we have e of x of t1 times x of t2 minus e of x of t1 to the power of 2. So in this calculation, we can see that r of t1 and t2 has appeared, and we know the left side. We have calculated this before in the first lines. So we'll substitute this, and we will substitute this as I showed you and I have calculated in the question number 9. So easily we can get to r of t1 and t2. But we should be aware that we had some assumption that t1 is greater than t2 is greater than t1. So if we have it the other way, I mean, if t1 is greater than t2, this formula will be the same. Only lambda times t1 would be substituted by lambda times t2. So we can write down this part here plus lambda times mean of t1 and t2. And yeah, thank you. That was my answer to question number 8.